Picture this. Everything you've ever known, every star twinkling in the night sky, every planet spinning silently in the void, every galaxy swirling in cosmic dance, and even you, sitting there, reading these words, could be trapped inside a colossal, rotating black hole. What if the universe, the vast expanse we call reality, isn't what we think it is? What if it's the interior of a monstrous cosmic beast, a black hole so immense it swallows not just light, but the very fabric of another reality beyond our reach? Buckle up, because a groundbreaking new study is shaking the foundations of cosmology, suggesting our universe might be a spinning black hole, and the evidence is more shocking than you could ever imagine. For decades, black holes have haunted our imaginations as the universe's ultimate predators. These enigmatic voids, where gravity is so intense that not even light can escape, have been the stuff of nightmares and science fiction epics. But now, science is rewriting the story, and it's more mind-blowing than any Hollywood blockbuster. A radical hypothesis, known as black hole cosmology, is gaining traction, and it's not just some wild theory cooked up in a lab. It's backed by cutting-edge observations, mathematical wizardry, and a growing chorus of scientists who are daring to ask, what if our entire universe is the inside of a black hole? This isn't just a thought experiment, it's a scientific bombshell that could unravel the mysteries of existence itself. The idea first flickered to life in the 1970s. But it's only now, with the latest technological marvels and theoretical breakthroughs, that it's stepping into the spotlight. Imagine the universe as a cosmic Russian doll, nested inside a black hole that exists within another universe. Sounds insane, right? But this theory could explain some of the most perplexing puzzles in cosmology, from the origin of the Big Bang to the eerie fine-tuning of the laws of physics that allow life to exist. Let's dive into the jaw-dropping evidence that's got scientists buzzing. In 2023, the James Webb Space Telescope, humanity's most powerful eye on the cosmos, beamed back images that left astronomers speechless. When peering at galaxies billions of light-years away, researchers noticed something bizarre. These galaxies weren't just scattered randomly, as you'd expect from a universe born in a chaotic Big Bang. Instead, they showed a preferred direction of rotation, a cosmic choreography that defies everything we thought we knew. This alignment screams one thing: our universe might be spinning just like a rotating black hole would. Why is this such a big deal? A rotating black hole isn't just a static void, it's a dynamic beast, twisting space-time into a cosmic whirlpool. If our universe formed inside one, that spin could leave fingerprints on everything from the way galaxies move to the very structure of space itself. Mathematical models are now showing how the insane gravitational forces inside a rotating black hole could trigger a kind of cosmic rebound, creating a new expanding universe, ours. This isn't just speculation, it's a hypothesis that's starting to stack up against the data. Now let's talk about one of the most mind-bending ideas in modern physics: the holographic principle. Imagine the universe as a cosmic hologram, where everything we see, every star, every planet, every atom, is just a projection of information encoded on a two-dimensional surface that surrounds us. It's like living inside a 3D movie, projected from a 2D screen. Crazy? Maybe. But in 2022, physicists at a leading particle accelerator detected tiny quantum fluctuations in space-time that match what you'd expect if our reality is encoded on a boundary, just like the event horizon of a black hole. These quantum jitters are like cosmic breadcrumbs, hinting that our universe might be a hologram inside a black hole's skin. But hold on, how could the entire universe, with its billions of galaxies stretching across unimaginable distances, fit inside a black hole? Black holes are supposed to be small, right? Not quite. Thanks to Einstein's theory of relativity, things get weird inside a black hole. Space and time twist in ways our brains can barely comprehend. What looks finite from the outside could contain infinite space within. It's like stepping into a TARDIS, bigger on the inside. This means our vast universe could comfortably exist inside a black hole. No matter how small it appears from the outside, here's where things get even wilder. There's a lesser-known extension of Einstein's theory called the Einstein-Cartan-Sciama-Kibble theory, and it's a game-changer. This theory adds something called torsion to space-time, which accounts for the intrinsic spin of matter. When spinning matter collapses into a black hole, this torsion creates a repulsive force that stops the collapse from forming a singularity, an infinitely dense point where physics breaks down. Instead, the matter bounces back, potentially creating a wormhole, a cosmic tunnel that leads to a new universe. That's right, our universe might have been born from a wormhole inside a black hole. This idea flips the Big Bang on its head. From our perspective, the Big Bang looks like the explosive birth of the universe from a single point 13.8 billion years ago. But if we're inside a black hole, that bang might just be the moment our universe emerged on the other side of a wormhole. To the parent universe outside, it's just another black hole doing its thing. The Big Bang wasn't the beginning of everything. It was a doorway, a one-way ticket to our reality. Now let's talk about quantum entanglement, the spooky phenomenon that Einstein famously called action at a distance. When particles become entangled, they're linked in a way that means the state of one instantly affects the other, no matter how far apart they are. In 2019, groundbreaking research suggested that entanglement and wormholes might be two sides of the same coin. Entangled particles could be connected by tiny wormholes, and if that's true, the quantum entanglement that holds our universe together might be evidence of a massive wormhole, the throat of the black hole we're living in. It's as if the universe is stitched together by invisible cosmic threads, all leading back to our black hole origins. Have you ever wondered why the universe seems so perfectly tuned for life? The laws of physics are balanced on a knife's edge. If gravity was slightly stronger or weaker, stars wouldn't form, planets wouldn't exist, and life as we know it would be impossible. This fine-tuning has puzzled scientists for decades, but the black hole universe model offers a tantalizing explanation. If universes are born inside black holes, they might undergo a kind of cosmic natural selection. Universes that produce lots of black holes create more offspring universes, passing down their physical laws. Over time, universes with laws that favor star formation, galaxy creation, and black hole production become the most common. Our universe, with its life-friendly physics, might be the result of this cosmic evolution. The technology to test these ideas is advancing at breakneck speed. Gravitational wave detectors, like the ones that first confirmed Einstein's predictions, are now sensitive enough to pick up echoes from the dawn of time, ripples in space-time that could have originated in the parent universe. Meanwhile, scientists are using tensor networks, a tool borrowed from quantum computing, to model how information might flow from a parent universe into ours through a black hole. These models are starting to match real-world observations in ways that make even the skeptics take notice. Another clue lies in the cosmic microwave background, the faint glow of light left over from the Big Bang. This ancient radiation is like a snapshot of the universe's infancy, and scientists are scouring it for signs of rotation. If our universe was born inside a spinning black hole, this light should carry subtle asymmetries, like cosmic fingerprints from our universe's birth. Recent measurements have found hints of these patterns, and they're eerily consistent with what a rotating black hole would produce. The standard Big Bang theory has been the cornerstone of cosmology for decades, describing a universe that burst into existence from an infinitely dense, scorching hot point. But it's always left nagging questions unanswered. What sparked the Big Bang? What came before it? Why did the universe have the exact properties needed to form galaxies and life? The black hole universe model offers answers where the Big Bang falls short. It suggests the Big Bang wasn't a random explosion, but a natural consequence of a black hole forming in another universe. Our universe didn't come from nothing, it was born from something. This model also tackles one of the biggest headaches in cosmology, the horizon problem. The universe is eerily uniform in temperature, even in regions so far apart that light hasn't had time to travel between them since the Big Bang. How could these distant corners of the cosmos be so similar if they've never interacted? The standard answer is cosmic inflation, a super-fast expansion right after the Big Bang. But inflation requires exotic physics we haven't fully pinned down. The black hole universe model offers a simpler solution. Our universe inherited its uniformity from the parent universe, baked into its DNA during the black hole's formation. Speaking of inflation, the black hole model gives it a new twist. As matter collapses into a black hole, space-time stretches dramatically, creating a rapid expansion from the perspective of anything inside. Sound familiar? That's exactly what cosmic inflation looks like. The black hole model suggests inflation wasn't some mysterious add-on to the Big Bang, but a natural part of our universe's birth inside a black hole. Then there's dark energy, the mysterious force driving the universe's accelerating expansion. In standard cosmology, dark energy is a head-scratcher, a force we can't explain. But in the black hole universe model, it emerges naturally. As matter keeps falling into the black hole from the parent universe, our universe, the interior, expands like a balloon inflating with every breath. Dark energy might just be the universe reacting to the steady influx of matter from beyond. Now let's talk about white holes, the cosmic opposites of black holes. While black holes suck everything in, white holes spew everything out. Matter, energy, even light. They're purely theoretical, but Einstein's equations say they're possible. In the black hole universe model, the Big Bang itself might have been a white hole, the point where our universe erupted into existence from the other side of a black hole's wormhole. It's a poetic twist. The moment we think of as the birth of everything might be the exit sign of a cosmic tunnel. The implications of this theory are nothing short of staggering. If our universe is inside a black hole, time itself works differently. Thanks to the insane gravitational effects near a black hole, time in the parent universe could crawl while billions of years zip by in ours. The entire history of our universe, from the Big Bang to the formation of galaxies to the rise of life, might be just a fleeting moment in the parent universe's clock. It's humbling, isn't it? Our epic cosmic saga could be a blip in someone else's story. This theory also opens the door to a four-dimensional black hole. We live in a universe with three spatial dimensions, length, width, and height, but physicists have long speculated about extra dimensions. A four-dimensional black hole would have a three-dimensional event horizon, perfectly matching the structure of our observable universe. Recent calculations show that such a black hole could create a three-dimensional brane, a membrane-like universe like ours, that expands naturally. These models are lining up with observations of the cosmic microwave background better than some traditional theories. The flatness of the universe is another mystery this model solves. Our universe is almost perfectly flat, a geometric quirk that requires incredibly precise conditions in the standard Big Bang model. It's like flipping a coin a trillion times and getting heads every time. An unlikely stroke of luck. But in the black hole universe model, flatness is just part of the package, a natural outcome of the physics of a black hole's event horizon. Even dark matter, the invisible stuff that glues galaxies together, might be explained by this theory. Some physicists suggest dark matter could be the gravitational influence of the parent universe leaking into ours, or the tidal forces of the black hole shaping our reality. Those tiny fluctuations in the cosmic microwave background, they might be echoes of quantum ripples from the parent universe carried across the wormhole into our own. The evidence is piling up from every corner of science. High-precision measurements of the cosmic microwave background have revealed subtle asymmetries that match what you'd expect from a rotating black hole. The polarization of this ancient light, how its waves wiggle, shows patterns that standard cosmology struggles to explain but fit perfectly with the black hole model. Gravitational waves, those ripples in space-time we've only recently learned to detect, are also dropping hints. Some signals show unexpected echoes, like waves bouncing off the walls of our universe's black hole boundary. Of course, this theory isn't without its critics. Some scientists argue that if we're inside a black hole, we should see clearer signs of its boundary, like specific distortions in the light from distant stars. So far, those signatures are missing, leading some to doubt the model. But supporters counter that these signs might be too subtle for our current technology or manifest in ways we haven't yet figured out. The interior of a black hole could even allow for stable orbits, meaning complex structures, maybe even entire civilizations, could exist inside without ever noticing their cosmic cage. Now let's zoom out to the multiverse, because this theory doesn't just stop at one universe. If our universe is inside a black hole, and our universe is filled with billions of black holes, each one could be a gateway to another universe, each with its own laws of physics. It's a cosmic nesting doll, universes within universes, stretching out to infinity. This multiverse perspective suggests that universes that produce more black holes create more offspring, leading to a kind of cosmic Darwinism. Universes fine-tuned for black hole production, like ours, become the dominant species in this vast cosmic ecosystem. The philosophical weight of this idea is crushing. If we're inside a black hole, the concepts of beginning and end lose their meaning. The Big Bang wasn't the start of everything. It was a transition, a rebirth from another universe's black hole. The end of our universe, whether it's a slow fade into darkness or a catastrophic collapse, might just be the prelude to another universe's birth. Our cosmic story isn't a standalone novel. It's a chapter in an infinite saga. This perspective also rewires how we think about time. Some physicists argue that time isn't a fundamental feature of reality, but something that emerges from the interactions of quantum systems. In a black hole universe, the forward march of time might just be the direction of increasing entanglement between our universe and its parent. Every moment we experience could be a step deeper into the cosmic web that ties us to realities beyond. The future of this theory is bursting with possibilities. New gravitational wave detectors, set to launch in the 2030s, will be sensitive enough to catch ripples from the universe's earliest moments, maybe even from before the Big Bang. Quantum computers are getting powerful enough to simulate the boundary between universes, letting us test the black hole model in virtual labs. Meanwhile, next-generation telescopes will map the universe's large-scale structure with unprecedented detail, hunting for patterns that could only exist if we're inside a black hole. But the biggest question of all is this: what lies beyond our black hole? If we're inside one, what's the parent universe like? Is it a chaotic realm with wildly different physics, or a familiar cosmos not so different from our own? Could there be beings out there studying the black holes in their universe, unaware that one of them contains our entire reality? The possibilities are as thrilling as they are terrifying. This theory isn't just about science. It's about reimagining our place in the cosmos. We're not the center of everything, not the pinnacle of creation. We're a small but wondrous part of an infinite tapestry, woven together by black holes that link realities across the void. Our universe, with all its beauty and mystery, might be one of countless others, each born from the heart of a black hole, each telling its own story. The universe has always been a place of wonder, but this new study makes it clear it's stranger, wilder, and more awe-inspiring than we ever dreamed. We're living in a cosmic enigma, a reality that challenges everything we thought we knew. So the next time you look up at the stars, let your mind wander. Those twinkling lights might not just be distant suns. They might be the glowing echoes of a black hole's embrace, a reminder that we're part of something far greater than ourselves. Stay curious, because the truth is out there, and it's more shocking than you can imagine. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Until next time, keep looking up.